Bob Martin was an avid maker before that word was a widespread term, tearing gadgets apart to see how they work his entire life. After obtaining his Bachelor of Science in Electrical Engineering from the University of Saskatchewan, his early career spanned everything from installing specialized instruments into Arctic weather stations to designing industrial control systems and supporting upper atmospheric research campaigns. Moving to the Bay Area 20 years ago, he continued his concentration on embedded systems. After a decade at National Semiconductor, which exposed him to the wonderful world of analog, Bob helped a few startups before landing at Atmel, where he managed a microcontroller applications team. There, Bob became deeply involved with Arduino and the Maker movement, supporting both 8 and 32-bit microcontroller platforms. With 30 years of embedded design experience, Bob continues his role keeping the maker spirit alive within Microchip, educating and inspiring makers and professionals alike. He continues to create, experiment, and explore as much as he can. Bob lives in Sunnyvale with his wife, twin daughters, and a cat with no teeth, along with a garage full of surplus wire and boxes of vintage electronics that really need to be recycled. Ladies and gentlemen, please welcome Microchip's Wizard of Make, Bob Martin.
Thank you, everybody. I'm so glad that you hung out. I know it's Friday afternoon, and I'm going to make some promises for this presentation. The only time you're going to hear me mention the word return path, impedance, decay, and FR4 is right now. You're done. Yeah. I would really deeply like to thank Altium for inviting me here. I want to do a shout out to some very special people. I don't know, Judy's sitting out in the front. She's been wonderful to work with, of course. And then Ben, if Ben's in the room. Ben and I met Ben, there he is. I met Ben at Maker Faire when Altium released Circuit Maker at Maker Faire. And I went across, this is bleeping amazing. And I ran over back to our booth. And for years, when I was at Atmel donated half our booth space to Arduino. And Massimo was sitting there. I said, Massimo, we're going to be able to finally break away from the CAD package that rhymes with Beagle. And almost there. But that said, because Altium is the base design package within Atmel/now Microchip, I have a few holdouts in another team in France, but I can only do so much, right? So again, what I'm talking about, or what we're going to talk about first is like Wizard of Make. Come on, man. It's actually on my business card, and I conveniently forgot my business cards, but I can post proof. This is a, why is the feed not updating? Hello, Wizard of Fix. All right. Comes in, comes out. No? Well, that's inconvenient, isn't it? Yeah. Yeah. All right. Come on. There it is. Okay. But now we're on the, I'm not cloning the display thing right now. Thank you, Microsoft, for starting. Yeah. Are you sure you want to update now? No. Like literally no. That's not happening right now, trust me. Although I expect it to any second, given what's going on. Yeah. Like literally, we can land school buses on the moon. But are you kidding me? Hang on, output, clone displays. Output to clone displays. Like, come on. Sorry about this. Like literally, but built-in display plus digital television. Yeah! Woohoo! Man, all right, so that was smooth. All right. Okay. I need to bring out my little ray gun from Men in Black, right? Okay, no, never mind. There we go. Wizard of Make. So, my official entry in the Microchip HR system is Senior Staff Engineer, SME. SME stands for Subject Matter Expert on Rapid Prototyping. When I was even before I started at Atmel, it kind of came out of coming on the back half of National Semiconductor. I had a reputation for throwing together embedded Linux systems in record time to solve customer problems. And that's where the word wizard came from, because I used to go to training, hold training classes at National's FAE training. And a lot of the FAEs said, Bob, you're like a wizard, and you brought this together, because I said, look, I just threw this system together 2 days ago, and they could tell by the time date stamps on the hard drive. What I am now, so I brought that in, the Wizard of Make, because I was so involved with the maker community, that the Wizard of Make came along. I am the main technical liaison for Microchip for companies such as Arduino, Adafruit, SparkFun. Lamore and Philip from Adafruit, we're trading emails on a very regular basis. Massimo and Dario Panizzi at the hardware lead at Arduino. We're trading emails all the time. I haven't gone out and talked to SparkFun for a while. I am very remiss, so if guys from SparkFun are watching this, I'm sorry, I'll get you out. One more shout out to Eric Bogatin, who called me out yesterday and called me out in the good way. Eric, when you're watching this video, I was deeply honored when you called me out. I'm gonna come see you in Colorado, I promise. So what do we do now? I represent Microchip at Maker Faire worldwide. There's an asterisk there because a lot of you know that Make Magazine went under. I don't have time to get into the full story of kind of what that happened and what that means for Maker Faire. Maker Faire Rome is still happening in the middle of October, in about 2 weeks. I'm not going because it's my wife's 50th birthday, and I can't afford to lose that many points. So, and again, part of my job not only is to go into detail about what we're gonna talk about, or what I'm gonna talk about, is moving people from Arduino proof of concepts into production. I create material and slides and training courses exactly on what I'm going to talk about to help people move that. Now, a lot of you out there are working for companies that do not start POCs from Arduino platforms, and I completely get that. But what I see, my people, the people I meet at Maker Faire, you may recognize companies like Little Bits. You ever heard of Little Bits? They make the little magnetic coupled electronic circuits. Little Bits I used to host in our booth at Maker Faire. Aya Badir, the CEO, and it was really encouraging and heartening to me to watch that company grow when she and just like 2 of her employees were just having one table at Maker Faire. And I was proud to be a little part of that cycle. So, the Wizard of Make came to a head last year when my wife gave me a bobblehead with the Wizard of Make title underneath it. Apart from the cape and the wand, that's exactly my outfit that I wore for 3 days straight at Maker Faire. Well, that's what I wear for 3 days straight at every Maker Faire. I do laundry before, or between, trust me. The Wizard of Make bobblehead took a tour of Europe. Every year I try and get into both Norway, where the AVR microcontroller was designed, and Torino or Turin, depending on which map you're reading or what website you go to, Italy, where the main Arduino R&D center is. And the gentleman to the right of me, or your left, is Fabio Volante, the CEO of Arduino, and I don't think I need to describe or identify the gentleman with the goofy expression on his face. That is, of course, Massimo Bonzi, one of the co-founders of Arduino. The other gentleman with the big smile on the last slide is Martino Fascin, who is the lead software developer. And Martino and I interact a lot because of the dominance of Microchip microcontrollers on Arduino platforms and making sure that everything is lining up. So I've become my own brand, which is kind of cool. So again, what I've seen in my interactions, and again, little bits is one of them. Another thing, it's become one of the default standards for rapid prototyping in the makerspace, in what I call the pro makerspace, in literally the startup community as well. Again, yeah, senior citizens' homes are having training courses on Arduino. Honest. And it's not part of the reason it was successful. And being from the semiconductor, I've been, like I said, since I moved down to California, I've been working for both startups and large corporations. The one thing that companies that I work for, like National or even Atmel and now Microchip, have always struggled for was to come up with that zero barrier to entry for learning microcontrollers and embedded. It is that magic combination of electrical engineering and computer science and knowing how to solder, right? And my wife says, you are literally the most patient person I've ever met. And when you were growing, and some of you maybe cut your teeth on 68HT11s or 6502s or 8031s. Man, that was, yeah, like literally, I remember during my first job, I had an 8032 external flashed EEPROM, the windows, so I was always smelling ozone all day. I was always baking the EEPROM parts. And I had an LED blinking, but it was blinking off a timer interrupt. So I had the timer, I had the clock tree going, had the external crystal going, had the interrupt system going, and I had a multi-threaded thing to blink, and then one LED, then I had another one. And my new boss comes up and he goes, like, that's it? And I went, are you kidding me? But anyway, yes, that's it. So there's some other magic that's happening when they put the Arduino system together. So we're going to have a little tour for a little bit on the Arduino environment, what made it special, the critical mass or the perfect storm, what came together for Arduino. Not only was the fact that they had the IDE and they had the right hardware and they had the support community, but what made the whole system work so well, and how could they get away with it just with a USB cable, a standard USB printer cable? And this is what the magic combination was. They looked at, as they were looking around for microcontrollers, and when it all started, when Massimo was teaching at that institute, and he still teaches there, so we need an easy-to-use microcontroller platform. And they came across the Atmel ATmega 328. Well, actually, they used the 168, but let's just standardize on the 328. The one important thing that it had, which was just a recent addition to the microcontroller space at that time, was the ability for that chip to self-program, okay? And that meant that, well, that means the students or whatever don't need to buy an external programmer, because that's money. Now, we only need another way to get that code in, and I'll talk about the bootloader when I get down to the auto reset function. The other things they took care of, which apparently as semiconductor manufacturers we weren't smart enough to figure out, is they put that, you've heard the term walled garden and referred to Apple, right? Well, they kind of made their own walled garden because they set up the clock tree for you, which is so critical in embedded. If you don't have a working clock tree, you have no heartbeat. If you have no heartbeat, you're not running code. If you're not running code, shut the lights off and go home, right? They set up timers, basic timers for you, and it's a zero-effort serial port, all came along for the ride. So you could execute code, you could time things, and you could get information out of that board without doing anything except calling the functions, which had very rational function call names. The unified API, based on wiring, which came from another language called processing, is actually fluffed up C++, okay? And the other thing that made this really pull together is there was a really good compiler, the new GCC compiler that Atmel had submitted to the open source was completely open source and completely free. And it's still a really decent compiler. So the line was the wiring shell. I mean, it looks like you're programming C++. You essentially are in the classic green and black and white IDE. You're essentially programming C++ that's letting you get away with some messy stuff. It's being translated to C++, it's being compiled into hex code, and then the third and the last part of the chain is how do we get that Intel hex file of nothing but raw opcodes for the AVR Mega 328P into some form where it can self-program. And what happens, another feature of the Mega 328 is we can partition the flash, and we can slice off the top layer up to a couple K, and we can kind of isolate it from the lower part of the flash. And that's where the bootloader sits. We can also tell the Mega 328, when you come out of a power on reset, don't start at the bottom to execute code. Start running the bootloader. Okay? Now we got a way to get in, except now we got a reset, and the earlier days, they were like hitting the upload button and tapping reset and trying to catch that cycle. And the hardware team's going, well, this is ridiculous. We have to have a way to do an auto reset. And they took advantage of a standard serial UART interface signal that isn't used much. I don't think it's used apart from Arduino anymore, except for people that are doing really high-speed hardware flow control on serial ports that are way up in the megs. The DTR signal, back in the teletype days, what happens when you open TerraTerm or you open up a COM port, that DTR signal would drop. Well, you can't just hook that to reset because now you're holding your part in reset and you're done, right? So what they did is they hooked the DTR signal to the reset signal through a cap, a little 0.1 mic cap, which meant, and then there's a 10K pull-up on the reset side. So when DTR drops, the cap dumps all the charge, the reset line dips, but then starts charging up again and pulls the chip out of reset. So that's that auto reset function. So when you hit that upload button, that's kind of the cycle that happens. It compiles the code, takes a hex file, and actually their bootloader is based on code that Atmel wrote called the Samba bootloader, and that's more history I want to go into right now, which is fine, it was open source. And the opening that COM port drops the reset, pulses a reset. The bootloader, its mission in life is to, after coming out of reset, kind of listens to the serial port for about 500 milliseconds for some special characters to come across the serial port. If it doesn't hear anything, it goes, now I'm going to go check for some code down in the bottom of flash. If it finds it, it starts running it. So when you're using Arduino, the only time that flash space is open is when that first bootloader's imaged. You're always just swapping new images. So that's my little overview in case you didn't know the mechanics of how Arduino gets code into those microcontrollers for essentially free, okay? So keeping that in mind, I want you to remember this as I'm talking about progressing into production. All right, this is what I call the jumper wire bouquet. And that is an Arduino Uno. The default reference educational standard for kids or anybody looking at Arduino. And I want to mention that Uno clone that Eric showed on how open source will get you into trouble. That is literally the worst laid out clone I've ever seen. And I know people that designed that board may see this thing. No, dude, that was a dumpster fire. It's like, and I'm kind of glad that Eric kind of displayed the problems with why it was a dumpster fire. Literally, I need to find the people that created these Gerbers really soon, because I know Arduino's on their tail too. But if the R3 is great for learning Arduino. It's not any more bulletproof than some of the things I'm going to talk about. But it's got lots of space, and it's kind of like the same width as those solderless breadboards, and Fritzing, which is a free CAD-ish package, right? You can draw literal physical connection diagrams. I don't know, maybe some of you have seen Fritzing. It's kind of a cool package. People say we kind of use it for schematic entering. No, but for like raw wiring diagrams for Arduino circuits, it's really good, especially for kids. Or teachers telling kids, they don't have to sit there and manually draw. Anyway, there are much better and smaller and more cost-effective and more relevant or appropriate boards from the Arduino family that I'm going to talk about, which are very, very close to optimal layout. But as I said, serious prototyping. The Pro Mini, the Nano, and the MKR series, and I'm going to show pictures of them. There are other things I'm going into, but Adafruit and SparkFun and Microelectronica, now they've branded themselves as Micro-E, have created a bus called the Click Bus, and it is literally what I call electronic Lego, and I'm going to get into that pretty soon. So here are the key form factors that have some serious potential for what I'm talking about is moving prototypes or POCs into production. It usually starts with one of these three boards or board families. The Nano, they released 4 new Nanos at Maker Faire Bay Area this spring. I'm going to talk about a little more. The MKR series, which is Maker, and unfortunately the footprint between Maker and Nano are not the same, just the way it happened. Pro Mini, the Arduino Pro Mini and the Arduino Pro are the only, and the Pro Mini is basically the smallest Arduino you can buy on through a reputable site. There are like Picos and stuff like that are literally as big as a 328. But you can see it's basically a dip breakout package with an LDO and an oscillator on it. The Pro Mini and the Pro are the only 2 Arduino boards that are manufactured outside of Italy, not by Arduino. They're manufactured by SparkFun, who have official licenses to produce these boards. If you turn a Pro Mini over, you will see the official Arduino infinity symbol with the plus minus in it. It is an official product as opposed to the clones. And I'm going to just cover something now. I think the slide's coming up later. They understood. They said, hey, this hardware is open source. Go clone it. Absolutely. What we're finding, what Arduino's having trouble with right now, and not only does it cause trouble for Arduino, it literally causes trouble for Microchip, and specifically me. Because some of these clones coming out of across the pond are so, like that board that Eric brought up, are so poorly designed that they start failing prematurely. And they'll phone up Arduino and go, your boards are crap. And go, Does it have the infinity symbol on the back? No. And that's what upsets Massimo and company. When they have to waste time, money, and resources trying to explain to this person, we didn't build that board. The next step, believe it or not, and I have taken phone calls from angry people that have bought Arduino boards off of Amazon claiming that our chip is broken. It's like, dude, do you know how many billions of Mega 328s we've shipped? Do you think we just suddenly forgot how to make them overnight? You know, it's like, dude, you know, they're made in Boulder, not Boulder, Colorado, Colorado Springs. Atmel, now Microchip, has a huge fab, and that fab is almost 100% allocated to the Mega 328s and that part of the Mega series. It's not like they keep the recipe on a magnet in the fridge. It's like, okay, what are we doing, 328s or, you know, cannoli? No, let's do 328s today. So not only did the clones affect Arduino, they affect me because I was known as the person that was supporting Arduino. I'm going, what am I doing taking angry phone calls from people saying, dude, buy a new board and pay some more money for it. I said this electronic Lego. Had this stuff been around when I was like the pre-turbo geek, which apparently now Lawrence is saying it's trending from Joe's presentation, that's really cool. A little frightening, but really cool. Between this and we have a good relationships with Microelectronica and their clickboards, we actually directly support Microelectronica boards in our development environments. And the reason I'm mentioning Atmel Start and MPLabX code configurator is because I'm going to be talking a little bit more. This is not just a hardware presentation. I'm throwing in some software in there, but I realize most of you guys are hardware people. But again, it's the whole ecosystem of Arduino I need to talk about. It needs to be the full story because moving prototype means moving the system. And it's embedded system, you're dragging firmware along for the ride, right? Okay. They just have a frightening amount of clickboards, and I'm receiving no kickback from Microelectronica on this. I'm just saying it's a prototyping system. Again, in large companies, you're not going to be using Microelectronica buses. For startups, have a look at them. So I went from solderless breadboards, and I started doing Stripboard. That was popular in Canada, and it's more popular in Canada than Britain. So it's protoboard, but there's strips of copper. You've seen it, right? And there's actually a CAD package that will route a schematic and tell you where to cut the traces and put jumpers across. Then I still, for really rudimentary and quick things, use Stripboard because I kept running into connection integrity problems with the wireless breadboard. It's great for blinking an LED in a classroom. But this is my prototyping level now. And I walk the walk, and those are from starting at the left. That is a weather station prototyping design. It's an open source weather station design I used during our IoT week at Microchip. So that's an Arduino Pro Mini, and the 3 blue boards, which have remarkably very close to the same footprint from Adafruit. There's a BME 280, which is a temp, humidity, and atmospheric pressure sensor. The other one is a volatile organic compound sensor, and the other one is a UV index sensor. And I threw this board together, and there's no copper pore on the top because I use this board to help teach in a underprivileged high school in San Jose, basic electronics. And they can really, it's easier for the kids to look at the traces and follow the traces as it goes from board to board to board from the I2C bus and how things come out and where the power comes in. The middle board is a motherboard that I designed about 2 months ago. And as I was explaining, for those of you who I met or I was talking to around the robot competition last night. That was the main motherboard, and it did run a click. The Microelectronica click board is that green board right there. It's a 16-pin bus. I don't need to get into details about it. And it actually wasn't running. I've got a Nano there, but I don't need a Nano with an RF. That was the Nano controller. It was for a robotic tank battle game that I promised our marketing team, our Marcom team, would be ready for ARM TechCon, which was happening the same week as this show. So the reason I didn't want, or I thought it was really cool last night, the robot competition, but I had spent so much time building robots in the past 2 months, mentally I just was not ready to start putting another robot together. I just kind of broke out in a chill. And it was a really great event. I think it's an awesome event. And I was talking to Ben a little yesterday on, I have some ideas how to jazz that up, because I'm not a big fan of like battle bots. I'm more of a autonomous program, a task thing. So hopefully we can work something out. The last one is just a general power supply board. Well, it's more than a general power supply board. It's a IoT base power supply board, which allows me, it can be a base for the weather station, but it's a general purpose board, because the Nano that's sitting on there is an IoT 33 Nano, which gives me a SAMD21 microcontroller and Wi-Fi, but I can drop in another Nano that gives me LoRa. So, and it also inputs like up to 28 volts DC. So that switcher module I buy from Amazon for $1.50, I think. It's an LM2576. I was at National when that part was being designed. The BOM cost, the DigiKey price at $5K for that, the switching regulator is like $3. I buy the complete module for $1.50, right? I am not designing my own LM2576 power supply ever. I mean, I'm not going to build 1 billion of these things, but I maybe push 200, 300, 500 PCB boards out the door a year on my own. There's no way. $1.50, yep, click, Amazon Prime, thank you. This is kind of the space I'm in, and this is where some of the topics I'm going to talk about. So people will drop ESP8266 modules down. Well, let's start talking about why not take the same approach from Arduino. And I made up this fake project, the Bunco Scoremaster 2000. And I deeply, deeply wanted to get my prototype here and working. You all know about Bunco? It's soccer mom's liar's dice, right? 5 dice, no math. My wife's part of a Bunco team. I introduced it to one of my local bars back home in Sunnyvale, and it's like they're freaking out going, it's a lot easier. And yeah, I won't go into it because it wasn't intended to be a bar game, but it turns out it's a really good one. So look it up. There is actually a World Bunco Association. That's why the R's behind it. And I eventually will get this going, and maybe next year, you can bask in the glory of a Bunco Scoremaster 2000, but I just ran out of time. But let's say that this is, without a doubt, a project that would have been prototyped on Arduino, right? If I said, hey, with the Bunco Scoremaster 2000, I was like a hardware accelerator. What's your product? Well, it's a Bunco Scoremaster 2000. What does it do? It blah, 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 automatically scores Bunco and distributes, party chip, salsa pour or whatever. Yeah, that came from an Arduino platform. They're not using my Amoeba Raspberry Pi, but it's an Arduino, right? So, you're going, holy crap. My friends and family are buying this and we want things. I got to scale up production. I'm first going to talk about software because in proof of concepts, embedded proof of concepts, that's just as important as hardware, because without the firmware, the software, nothing happens. It's just a board that drains your battery. And the first thing we provide, well, not the first thing, apart from the services, a key support element that we do at Microchip, and I teach classes in this. I've taught, man, I don't know, 50 classes? I've literally probably over 1,000 people I've taught this. It's the Advanced Arduino Debugging class. Using Atmel Studio and soon to be MPLAB X, you can import an Arduino sketch and turn it into a real C++ project and do source level debugging, right? And it saves you time, space, plus now you get your Arduino sketch into a professional development environment. And I'm going to show you, because there's a lot of people that were poo-pooing, the Arduino runtime code, it's crap. And literally, I've got, like I said, over 30 years of embedded experience. It's not that bad. And I'm following the thing, if it ain't broke, don't fix it. There are places, yes, where you're going to need to optimize your code, and you can write it. Once you get into Atmel Studio and MPLAB X, you can write your own professional level C++ code, or C code, it doesn't matter. But if you only need the serial module to output debug information, and you're done, in these professional environments, you can just like point and click and rip out that serial information if you're running out of flash space, and you're done, right? So I've got a screenshot of it, but I'm actually going to, if you'll bear with me, actually pull up Studio, because I find, and I'm not going to go through the whole cycle here. So this is the ubiquitous Blink program that every new Arduino board is shipped with. And it's much like that Arduino clone. I've got a couple videos up on YouTube for this class. And one guy, oh, that's not, man, I'm ruining my surprise. That's not Blink. Man, I took the thunder out of my own presentation. That sucks. This is the Blink program. Yeah, and people are going, yeah, I reckon that looks better. Right, turn on LED, wait for a second, turn it off, wait for a second, loop until dead. Okay? I put this, there's one class, and I go and check the comments and see how many hits I had on my various videos. And one guy goes, dude, use delay, I've no respect for you. And I'm going, it's the bloody Blink example. It's not like, that's not a reflect. Anyway, I didn't take it that personally, I just thought it was funny. It's like, you missed the whole flippin' point of the video, so thanks. All right. All right, so now we've added more than just color highlighting, right? Because again, I can set breakpoints, and again, I'm not gonna, now I can run, and Blink's gonna stop there, and I'm dumb because I didn't bring a board that's got a debugger on it. We're gonna talk about debug and programmability when you're moving Arduino platforms into production anyway. But the other cool thing is, and this is where, if I go down to digital write, which people, if you've used Arduino, you've used digital write, and I go to implementation, and I go to there, I bounce to the actual C code that implements digital write, okay? Because all along there, if you look along the left-hand side, wiring_digital.c is part of the Arduino runtime library that comes along for the ride, and that's where digital write gets implemented. So now, and it's consistent with the themes as Altium brings more features into Altium Designer, starting from a function called inspector. It's all about visibility. The more visibility you have, the better your design can be. What the sketch import does in Atmel Studio and MPLAB X is the equivalent of, PCB inspector or those inspection tools or the properties panels within the hardware. This is now full visibility into the software domain, which is not what the original Arduino IDE had, because you can imagine if, 8-year-old kids booted up an IDE that looked like that, that would be a big problem. Not, there's some brilliant 8-year-olds out there, but that's a lot of icons, right? And so once people start looking at that, because people will tell me, it's like, no, the code's crap. It's like, well, how do you know? Have you even looked at it? And it's pretty clean. Yeah, there's some overhead there, but that overhead improved over the last couple of years when they split the code repositories from the 8-bit and the 32-bit. They split those two apart. And that removed something, for those of you who do write code out there, you familiar with a term called pound def hell? Yeah. That cleaned up thousands of lines of pound def hell. Because you're trying to make 8-bit code and 32-bit code live in the same kind of programming API environment, you have to add a lot of fluff that just gets in the way, both mentally and performance-wise, right? For those of you who code, you can appreciate that. All right. So, okay, we've kind of, hopefully, at least I've convinced you that have seriously addressed the software issue. And again, this is, Altium, this is a hardware conference, so I'm going to spend most of my time on the hardware. But please, if you want to ask me more about that, if you know people or you're a startup and you want to know about this, or when I'm going to teach this class again, come talk to me. Because at Sensors Expo earlier this year in San Jose, I put this class together, or I put this class up, and I told the organizer, Sean, who put together Sensors Expo, and what he's trying to rebrand and revitalize the Embedded Systems Conference, which used to be the default go-to for the Bay Area for embedded systems. And I said, I can handle about 30 people in the class. Otherwise, the dynamic range gets too big. People are way too far ahead or way too far behind. So shut the website registration off at 30. He phones up our Marcom team the Thursday before the show and said, wow, that's great. Bob's got 168 people registered for his class. The Marcom team's now slightly freaking out. He updated us on the Monday before Sensors Expo. We got 323 people registered. I'm going, are you kidding me? It's like, this is not a university lecture thing, so yeah, long story short, I'm going to be holding more classes up in the Bay Area, and I actually have taught this class at UCSD, because I've worked with the UCSD Electrical Engineering Department. Dr. Nguyen, he just stepped down from the chair of the Electrical Engineering Department at UCSD. I know him pretty well, too, and I've taught several classes at UCSD about things like this. All right, hardware. All hardware guys, or, I assume so. What are your choices? Taking a POC, a prototype. I kind of grouped them into three main ones. There's some gray areas always. Board reflow, Arduino design injection, and ground-up design, which is kind of like the obvious conclusion a lot of people thought you had. So Arduino board reflow. This is kind of, and again, gray areas suitable for different levels of production. You're not going to do Arduino board reflow for really, really high production levels. But, as I said, they introduced 4 new nanos at Maker Faire Bay Area. They had 2, apart from new technologies, new chips and new technologies on the nano designs, they had 2 really important physical changes from the previous nano. And the nano is one of the most popular, if people are embedding stuff into projects, there are full production sprinkler timer systems and things like that, home security systems, that are actually stuffing in nanos as that default unit. The 2 changes they made were they moved all the components, okay, 3. They moved all the components up to the top side, and they put castellated pads along the side, which means now you can just drop down the pad footprint and reflow that module down. They also, in preparation for getting a larger audience where they're going to buy these boards, you know, and do this. They improved the power supply design. They threw on a switcher to pop the input voltage up, the allowable input voltage up to 21 volts and more output current, which meant it reduced the need to design another external power supply around it to push everything else, all the sensors and actuators, whatever you had, that was hooked up to that Nano, okay? So now you can just drop the board, and I'm going to get to how that's logistically going to happen. These are the module reflow candidates. The top two have Microchip parts on them. The bottom two do not, but that's okay. We've gone from 100% of, pretty much 100% of Arduino platforms to high 80s, and that's just the way it is. Oh, by the way, back about 5 years ago, the AVR Mega family was in literally 100% of every 3D printer being sold on the market, okay? If you look at the reference motherboard designs, it's a Mega 2560 with a whole bunch of stepper motor drivers around it. And again, as features keep getting better and, you know, or, you know, performance improves, you know, the market share goes down, but it's tough to keep on to 100% of the market, right? So yeah, module reflow. Low to mid production runs, yeah, obviously. It's a certified module footprints and reflow profiles will be available. I missed a word there. They will be available. Arduino, I have personal, again, I was in Turin, Italy for a week, and I sat down with Fabio and I said, I need confirmation face-to-face that there will be bulk pricing available for people who want to run production. Otherwise, you know, there's some advantage, but people are going to be looking for price cuts as they move up in production. He also assured me that they can meet production levels up to like a couple thousand boards a day. So, because I wanted to make sure that someone didn't like, yeah, but wait a minute, they can't build that many boards. Yeah, they can. And another big advantage is, and I don't know how many people of you saw my colleague's presentation, Pete Wilson's presentation on RF module injection. Again, one big thing, one huge removal of hassle and expense is dropping down a certified RF module. And if it's smashed up against a microcontroller and everything's working nicely because it's been through test and all that good stuff, so much the better, because you have a drop-in processing element. And I'm going to refer back to that processing element later in the presentation. Again, the drawbacks, the obvious one is cost, right? I'm not going to over-explain that. You're also bringing along components that you don't necessarily need along for the ride that's already on the Arduino board, but it's pretty much a power supply, and the ones with the RF, a power supply, a microcontroller, and the RF module. And that's basically it. That's what the Nanos and the MKR boards were designed to be, is minimal I/O breakout platforms, rather than the Arduino Uno has a bunch of extra protection and stuff like that, but there's some extras, but maybe not. And then the other thing is during production, depending on if you're gonna do a single cycle pick and place reflow, or maybe you're gonna have to reflow too when you first reflow your base board and then have to reflow the Nano module or the MKR, just the Nanos now, because those are the only ones that have the castellated pads right now. That's the drawbacks, obviously. Module injection is kind of the middle ground between direct module reflow and ground-up design. And within Altium Designer, there is a Rhymes with Beagle design importer that inputs boards, libraries, and schematics. And I translate, or have translated and cleaned up a lot of Arduino designs already, and I'm going to get further on, I'm going to tell you about, I'm not just doing it because I have nothing else to do on a Friday. The other thing that became really useful with this utility is I went out and downloaded all of SparkFun's libraries, and I imported them into Altium libraries, and now I have this vast collection of components and footprints that SparkFun uses. So when I buy SparkFun boards, I say, hey, that's a cool new breakout board. I want to replicate that on my own design. I've already got the PCB footprint and the symbol waiting there for me, right? And again, it's, you know, we were listening to a presentation about library management, going, that's a cool bonus. And not only does this work for Arduino, Adafruit, which I consider, between SparkFun and Adafruit, the reference standards in this electronic Lego, not only for building all these boards, but for the support behind them. If they got a sensor and they build a board, they've got a hookup guide and they've got an Arduino library sitting there for you. If I'm looking, and truth be told, for a lot of microelectronica clickboards, if I see the same part on a clickboard, I go to Adafruit or SparkFun to look, again, if I find one of the boards, I'll go download their Arduino library because I know it's going to work because they actually walk the walk and test that and have an example program to prove that it works, okay? That's another tip I'm going to give you if you're looking at this new sensor that came out from Bosch or whoever, you know, time of flight sensor or some new atmospheric sensor or, you know, gas sensor or magnetic Hall sensor. Do yourself a favor and go out and see if SparkFun or Adafruit have made a little breakout board. And if they have, you don't have to go buy the breakout board, but go check out the software library. But I would ask you that please buy some of their breakout boards, because that's how they fund all this thing. And they're really not that expensive, because you're going to save some time in hooking it up anyway. So that's my unsponsored plug for those two companies. So not the sketch importer, the board import actually works pretty well. There's some things you have to clean up, obviously. But what Arduino has also done, and they're working out the details as we speak, is allow you to import this and directly drop this design as a snippet onto your PCB design. And I'm not sure of the boundary conditions. There's a licensing fee that's going to be very minimal because they've lost the sale of the board, but it's not obviously going to be the same cost as the board. Again, this is Arduino's story to tell. So I can't tell you what that licensing fee is. That's Fabio's and Massimo's thing. And hopefully hopefully soon there's going to be a website with all this. Because I said all this information on the Arduino website needs to be painlessly easy to find. Or else people are just going to go, you can't be phoning Italy, right, all the time. They need to get all the information they need. Anyway, the board and the schematic import comes in fairly cleanly. You can drop this down. The other thing I don't know right now is how much, if you tweak this around, is it still relevant, that licensing thing? Again, those are details that Arduino's thinking about, because this was still in its infancy when I was out there in August. All right. The advantages are it's a known good design. And I'm going to talk about where the magic is in making an Arduino design if you're doing it from the ground. But it's a known good design. It's relatively size optimized, especially the Nano platforms. They're crunched pretty close together, and it's not HDI level of compression. But there's not a lot of wasted space on the new Nanos or on the Nano or MKR boards in general. And like I said, it's tweakable. Again, I don't know the exact boundary conditions of if you tweak it so much, that license doesn't apply. I'm sorry, I don't know, but hopefully we'll find out soon. And then here is the last one, which is the ground up. And I coined a term that Fabio may or may not start using. I call it the Arduino computing element. Literally, you're bringing an Arduino board up from the ground. And what do I need to do? How do I replicate an Arduino Uno or a Nano, a standard Nano, in the most space efficient, most cost efficient, least amount of time I need to figure out how to do it? Time. So I'm going to give you some tips and pointers depending on the, and this is relevant to any Arduino platform that they used. A Maker IO233, which is SAMD21 based, or the 328, so the new Mega 4809 AVR based. The magic in the ability to retain all the IP and effort that went into the software development that got developed maybe as a pure Arduino sketch or as a hybrid between the Arduino sketch and your private code. And if it's your private code and it's outside the Arduino runtime library, you can keep it. You don't have to push it up anywhere, okay? That's another misunderstanding that people have. It's the pin mapping. And I'm going to deconstruct an Arduino Uno for you in a little bit because I just brought up an Uno or a Nano Ace in Altium. You've got to use the same crystal. If it's an external crystal, if the board's got an external crystal, you need to use the same frequency at the beginning. You can change it later, but when, back to my thing on all that nitty-gritty that Arduino takes care of for you, the clock tree and the serial and whatever, boards are identified to the Arduino interface by a default clock frequency, which sets up the timers to 1 millisecond and also defines a default baud rate for the bootloader. And when you start messing around with the crystal, a bunch of that inherent stuff that used to work now is not going to. Same crystal frequency. You have to expose, and you're going to go, well, duh, the actual chip hardware programming and debug interfaces. And you're going to be surprised. So UPDI is now the standard new low pin count, as in 1 debug interface for all the new Mega AVRs coming out. It's an update to Debug Wire, which is last on the list, which is what the Mega 328 is, and SWD, of course, for the ARM parts. People are very surprised when I do my ARM debugging course to find out what pin we use for the debugging interface on the Mega 328P. Anybody know? It's the reset pin. When we go into Debug Wire, we program a fuse inside the 328, and we tell the reset pin not to be a reset pin anymore. It's a Debug Wire pin, and it's a bidirectional asynchronous interface. And that's how we download code and debug it. I'm not kidding. It's a reset pin. The programming interface on a Mega 328 is actually the SPI port. And if you got a 328-based system, an ACE, an Arduino computing element, you need to bring out the SPI port to an external connector, the standard 2x3 if you can, because how we program that ISCP interface, how that works is we hold reset, the programmer holds reset low, and the debug programming module on the Mega 328 listens for the serial clock in the SPI interface and traffic on MOSI. Because in that case, if it's in reset and we hear clock, or we detect clock on the S clock line, those two things put us in SPI slave mode, and we're in now programming mode. And you can't contaminate what's sitting on the actual SPI bus in your design because we're held in reset. There's no code running on the part. That's a programming-only interface. So that's what I'm saying. And I'm going to show you that in my Uno Ace reference design. All right. These are things you can mess around with. GPIO, things that you will probably have to. These are the base things of an Arduino computing element. An Uno, a Nano, base of Nanos, it's a 328P and a 60 meg crystal. And you can read the rest. There we go, reminder to self. All right. Let's look at an Uno Ace in Altium speak. Actually, it's in PDF speak, but this is the magic, the most important thing, apart from clock frequency and the type of part. See where that box where I said the magic happens is that pin mapping between the GPIO ports of that particular microcontroller that's on that Arduino platform. In this case, again, the venerable 328P, to A0, A1, and you can see patterns as they assign these pins to the Arduino pins. After you deconstruct your proof of concept and hook everything together, because you said, oh, okay, this moved to D1 or whatever, then you can start renaming the net lists. But what you need to do, and I'm going to be pushing these ACEs up to the Microchip hub on Circuit Maker. They're also going to be available on the Microchip website as well. These are your starting points. And then as you drop stuff down and understand how the net list between all your other stuff connected, then you can start renaming carefully the nets from the Arduino standard into your own standard. But this is where the magic happens. If you maintain this through the continuity and the connection and the net, the equivalent net list, they don't have to change a thing on the Arduino code. It will just work. That's the magic, okay? So here, again, it's a 328. This is a standard pin mapping. Here is the programming debug header. You're not going to, again, I don't need the serial interface, the FTDI converter, whatever. If I'm not using serial, you do not need that serial interface to get code into that part, because you're not going to be using the serial interface to do production level runs of imaging that part. There's no way. There's like 10,000 USB injections. Nope. You're going to come in through the debug header, and you can make that SMT pads with pogo pins, because it's literally a lot faster. Plus, you've got the debug interface sitting there because you've exposed the reset pin. There is the basic clock at 16 meg. Down here, if you're running the first couple runs, this is the standard pin out for the FTDI interface or all the clones that are coming out, that 6-pin interface. I just throw in that Schottky diode because at my years at National, I've known it's never a good thing to backfeed power into a USB port. And now with USB 3 being able, or 3.1 to be able to supply amps into you, yeah, I need some silicon barrier isolation, thank you. Okay? That's an Uno Ace. That's where you start from. And I guarantee you, if you keep your wits about you and the pin mapping, you'll be fine. Almost none. So everybody can go to the bar or whatever. All right. Or an airplane, yeah, or both. Again, I'm just going to finish up. I'm pretty much done. Okay, as I said, Circuit Maker Hub. We're also helping you out the other way. We've done a couple boards, the Microchip eval boards. There is now a concerted official project within the development tools group at Microchip to add more of our eval boards into the official IDE canon. And then once that gets all collected, I'm going to send a Git repository pull request to Martino Fascine, and hopefully in the next generation of IDE, we will be as many, we're not going to load every board, but this is the AVR Curiosity Nano. There's an onboard debugger on that board. And I think it costs $8, $10, right? So you can go back and use that Arduino sketch import utility. And that's the same part of the Mega 49 that's on the new Nano Every. So now you have a debug vehicle provided by Microchip. That was a Freudian slip after 3 years. All right. I just want to close this off. I really, again, for a lot of you, this is when we don't start with Arduino POCs, but my world is full of startups and pro makers, because the one thing that I'm always inspired, because when you're in an industrial environment all the time, it's always the same problems. And it's a lot of the problems you've been hearing about, sorry, I apologize, I'm going to say ground return paths one more time. Ground return, oh, that's 3, okay, done. But going to Maker Faire and you see these people with these ideas, and you go, that's brilliant. And if I can help this person in any way to bring this to a broader audience, I will do that. Because that's how I grew up. Again, we've seen many videos. We like solving problems, right? I love solving problems. I love helping people. Being an engineer kind of makes that a very rewarding career for me. You know, that's why I like teaching classes. My greatest fear, well, one of my greatest fears when I die, is I haven't shared enough of the tribal knowledge that's in this head to people out there. And I hope you all feel the same way, that you've collected this experience on how to solve problems and these anecdotes and these stories. And I really hope that you take some time to write them down or tell them to people. Because I think the greatest shame, I'm in the company of very smart people, all sitting in front of me. The greatest shame would to let that knowledge die. Yeah? I think that's really important to share that knowledge. I don't feel threatened sharing knowledge at work. I feel honored to be able to do that, as I have with you. Okay, soliloquy over. Don't start over. If you have to, come talk to me. I will do my damnedest to help you shortcut that situation. I will work with you tirelessly to produce the best design, because I know the parts, I know a lot of the sensors and the topologies that Arduino-based things start from, right? All right, thank you so much.